Let's get underway. Thank you for joining us, folks. This week's topic is materialized views, and like a huge pleasure here to introduce Fizaa. I don't know if you guys caught, we were just chit-chatting, but Fizaa was our intern at Facebook back in 2019, and she worked on some really cool stuff, and now she's back with us at Yugabyte full-time. So Fizaa, maybe quickly introduce yourself, and maybe talk about a couple of things that you did in your internship, and and I think you worked on materialized views as well. So yeah.
Yeah. So hi everyone. I'm Fizaa. I'm an engineer on the LRT team, which is the Language and Relational Technologies team. I started at Yugabyte last July, and before that, I also interned at Yugabyte in 2019. And yeah, I've primarily worked on materialized views, and then I've also, during my internship, worked on YSQL metrics and temporary tables.
Awesome, fantastic. And I was commenting how a lot more people use temp tables than I expected originally, but it's really awesome. Okay, so maybe I think a quick thing, folks, you can feel free to ask us questions right here on the LinkedIn comments, or you can join our Slack channel, yugabyte.com/Slack, and go to the YFTT channel. But either ways, don't feel shy. Feel free to ask questions. A lot more interactive and fun that way. Okay, so maybe Fizaa, kick us off with what are materialized views?
Yeah, sure. So I'll just share my screen.
Yes, please.
Okay, so firstly, what are materialized views? Materialized views are basically relations that contain the result of a query. Unlike regular views, they actually persist the results of the view query. And unlike regular tables, they cannot be directly updated. Instead, we have to use the refresh command, which re-executes the query and updates the contents of the materialized view. Essentially, they can be used in any scenario where we want to speed up the access to the result of a query at the expense of some storage. So you can think of situations where you have a foreign table and access to the foreign table is slow. So any queries that are executing on a foreign table, they run really slowly. So what you can do is you can use a materialized view to sort of store the results locally. Similarly, you can also use it for complicated joins or aggregations and stuff like that.
Got it. Got it. Like one, so maybe just a couple of clarifying questions, right? So a regular table, you can do inserts and updates, and your results would reflect right away.
Yes.
A view, right? The results would reflect right away, but it's evaluated on the fly. Whatever the view is, like however you construct it, it runs the command, but it gives you an object that you can interact with as the view, right?
Exactly.
And materialized view is kind of like in between the two, where the data is persisted but not updated right away. And but unlike a view, it doesn't have to execute the query again. It's kind of a read optimized version of data, but it's not updated immediately. Is that a fair thing to say?
Yeah, exactly.
Got it. Yeah, and I believe there are some relational databases like Oracle where the materialized view does get auto updated, but I believe Postgres you have to run the refresh command, right?
Yes, exactly.
Got it. Fantastic, fantastic. Yeah, please keep going. Thanks. Yeah, that was good.
So currently, materialized views are only in YSQL and not in YCQL. So like in Postgres, YSQL has.
But before maybe even we go here, right? Like what is foreign tables are one, but is there like a real world example to motivate, like for example, a scenario where this would be useful, say?
So for instance, if you have like you have an application which is sort of like an e-commerce store, and then you have items in your cart, and you want to like track which items in your cart are abandoned, you could use like a materialized view to sort of track that.
Got it. Because there'll be thousands and thousands of items in progress, and you want to put some rule to say if it's around for so long or whatever. And once it's done, you want to do the investigation. So yeah, that's a great example where you don't really need it updated right away, but you still need fast access to it, right? And you don't want to execute that query on the fly because it'll take down your online system. So yeah. Cool. Awesome. Thank you. Okay, let's keep going. So, okay, with that context in mind, like, okay, let's look at how do you use these things?
Yeah. So like in Postgres, YSQL also has 3 commands that are associated with materialized views, basically create, refresh, and draw. So firstly, we have the create command. It does what it says. It creates the materialized view as a YB relation. Here we can specify the query and the column names. And then we can also specify with data, which is the default behavior, or with no data. The with data option defines the map view and actually populates it, whereas the with no data option only defines the map view and doesn't actually populate it.
Got it. So
Yeah.
one question, if I do with no data on
Mhm.
a table that has data, it would just avoid doing anything but create an empty shell?
Yeah, it would just like define the map view and set it as unpopulated. And any subsequent like queries on the map view would like raise an error saying that, oh, you actually have to populate it. You need to use a
Got it.
refresh.
This is to split the creation of the object step from the actual population
Yeah,
step. Okay,
yeah.
got it. And in that case, how would you populate it? Just use a refresh or something.
Yes, just use a refresh.
Got it. Okay,
Yeah,
let's keep going. Okay, thank you. Yeah.
yeah. So this slide has like a basic example where you're performing a count star in a group by and we're creating an NV.
And what else can you do? Can you do joins? You said you can do joins, aggregations, a
Yes.
lot of other stuff, right? So pretty much any
Yeah.
SQL statement you can kind of put there and say, if
Yeah.
that's okay, got it. Makes sense.
Mm-hmm. So then we have the refresh command. This command is actually used to update the contents of the map view. Here again, we can specify with data, which is the default, or with no data. With data actually re-executes the query and repopulates the map view. So we actually generate new content and we update the contents of the map view. Whereas the with no data option, it can sort of be used to mark the map view as unpopulated, leaving it in an unscannable state. We can think of it as like sort of, using it to like sort of invalidate a cache, like saying that, oh, this is outdated, perform a refresh to actually get the updated data. Yeah.
So you can change it anytime. So you can mark it as with no data anytime.
Yes. If you use the refresh command, you can say refresh with no data. And then again, any subsequent selects will complain that, oh, you need to populate the map view.
Okay, that is nifty. Got it. Thank you.
So if you want to refresh with data, there are basically two modes. There's the default option and the concurrently option. Now, these two options essentially differ in the way they execute the refresh. The end result is the same. So firstly, we have the default option. In this option, we actually rebuild and reindex the relation. So you can think of this as better suited if there are a large number of new or modified rows. And another thing to note is that in Postgres, this option does block concurrent selects, but in YSQL, it does not. Any select that's happening in parallel will just see an older sort of snapshot of the data.
Got it. So this is because as a distributed database, when you're building it through one node, now it becomes an expensive block across all nodes. So I'm guessing we just decided to make it concurrent, irrespective, just build it in the background.
Yeah. And besides, like in Postgres, like two simultaneous refreshes can't run, non-concurrent ones, and that's the same behavior in YB. Like one of them will error out saying catalog version mismatch.
Got it. Because of the distributed cache coherence for the system catalog to detect that. Got it. So Kurt has one question, which is, given that YugabyteDB is distributed, how are materialized views distributed? Where is the owning set of node or nodes? How does that work?
So it's the same as any other YB relation. Like the behavior is entirely the same as any other like YB table that you would create.
So basically the definition of the materialized view will figure out the data sharding scheme and the distribution scheme and replication scheme. All of that is inherited from the parent, some parent object like the cluster or something, and it distributes it multi-zone, multi-region, multi-node, whatever it is, the same way.
Yeah.
So
co-location, everything.
Got it. So creating a table, creating an index, creating a unique constraint, or creating a materialized view, it uses the same substrate underneath, right?
Yeah.
Yeah.
Exactly.
So hopefully that answers your question, Kurt. Yeah. So it's basically the distributed mechanism, sharded, all of that. And materialized views can do dynamic split and can dynamically split and rebalance, and all of that should also remain the same, right? Because it's fundamentally the same thing underneath.
Yeah.
Cool. Awesome. All right. Let's keep going.
So then the second option is the concurrently option, the concurrently keyword. Here we actually construct a diff relation, which is sort of computed as an outer join between the old data and the new data, which is loaded into a temporary relation. And then based on the diff relation, we perform updates accordingly. So this is better suited if there are a fewer number of new modified rows, because you can think of that, like, in this situation, the diff will be smaller, and so the updates will be fewer. And so this option does require a unique index in the materialized view. Yeah.
Got it. Awesome. So there's one question from Samanvay, which is, he asks, are the nodes also replicated for materialized views? I'm guessing the question is really, is the data also replicated across nodes for materialized views, right? And I believe the answer is yes, right? It inherits the replication factor of the parent table or the parent relation, right?
Or like just the cluster.
The cluster. Okay. Yeah. So yeah, from the cluster. And it should be possible because it's the same substrate. Like whether we have enabled it now or not, it should be possible for us to modify and change the replication factor of a materialized view if necessary, right? Like we should be able to do all of that. So can you place a materialized view into a stable space? It should be possible, right? Like in Postgres.
Oh, table space? Yeah.
Yes. So there's your answer, Samanvay. So it's replicated just like you would by the default policy in the cluster, but you can create a table space which overrides that policy, saying you need a different distribution across zones, nodes, replication factor, all of that stuff. And you can put your materialized view into that table space and it will follow, so it just looks like a regular table. So hopefully that answers the question. Okay, yeah, let's keep going.
Yeah. And then finally, we have the drop command. Here we can specify cascade or restrict depending on whether we want to propagate the drop to dependent objects. Yeah.
Okay, fantastic. What's next? Do we have a demo?
Sure. Yeah. There's also,
if you have more things, go for it. Yeah. Finish it, and then
Yeah. So I also have like a slide based on just summarizing the differences between views, regular views, and materialized views. So basically, regular views, they do not persist the results of a query. Materialized views do persist the results. And for a regular view, the query is run every time we reference the view, whereas for materialized views, it's only rerun when we refresh it. So on the flip side, like regular views don't really have any maintenance cost, whereas for materialized views, we do have to run the refresh to get the updated data. So right now, the user would have to manually execute this refresh. But we do have the PG cron extension, which is currently a work in progress, which we're just trying to make it compatible with Yugabyte. And then once you have that, you can sort of automate the refresh as a cron job.
That is put in the database itself, right? Like the database will automatically run the PG cron.
Yeah.
Fantastic.
And so regular views, they're generally used when the data is accessed infrequently, whereas materialized views, they're used when the data is accessed frequently because we want to speed up the access. Yeah.
Makes total sense. So a few more questions. Okay, so maybe we'll take one and then we switch to a demo to answer Dennis's question. So Kurt's question is, how do you know when a concurrent refresh completes? I don't know if you're able to show that as a demo, like Fizaa, if you're able to show the background job when it completes and so on, but or if it's easier to answer it or however you want to do it.
So the concurrent refresh, like it completes when the command completes. The concurrent keyword in Postgres is actually used to signify that concurrent selects are possible in the materialized view. Whereas in Yugabyte, concurrent selects are actually possible in both scenarios. So the keyword is mostly just distinguishing the algorithm you want to use.
Got it. So Kurt, I think the refresh command does not return until the materialized view refresh completes, right? And if you say concurrently, then it will in Postgres allow you to do selects elsewhere. If you don't say concurrently, it wouldn't. And in Yugabyte, it would let you do that anyway. So concurrently is just more for backward compatible support. Here, it's going to let you interact with that object anyway. Okay. So, and I think Dennis had a question about if a materialized view executed the query and now needs to persist the result, where will the result end up being? How do we decide as a database which nodes, the partition strategy, and so on? And maybe that's easier to show with an example. I don't know, like you tell me, Fizaa, which way you want to
go. I don't have an example for that ready.
That's fine. That's fine. Yeah, that's fine. So yeah, but we can look at it maybe in practice, right? So let's maybe jump into it. We'll. Awesome. I can see. Yeah.
Yeah. Okay. Yeah. So here I just have like a simple base table. We can think of this as an ID and like some year of birth. And yeah, so this is what 5 entries of this base relation look like. You can see there's an ID and a year of birth. And excuse me. And so if we select count star, we see that the actual number of entries is 10,000. And now what I'm going to do is I'm going to create a materialized view with no
Before you
data.
do that, oh, okay, too late. I was going to say,
Sorry.
can you show that? Can you show like by listing that we don't have a materialized view? But that's okay. That's fine. Yeah, let's keep going. Yeah.
Oh yeah, now I'll show that the materialized view is listed.
That's fine.
Okay.
Now let's just show it's
Sorry
listed.
about that.
No worries. You were like lightning fast. That's fine.
Okay. So now I'm going to actually select from PG Mac views, and I see that the materialized view is listed in this catalog table. We see that the query's definition is under definition. And then because I said with no data, this materialized view is marked as not populated.
Okay, before we do anything, right? Like, do you have the YB Masters view, the browser view, like the 7,000 page?
Yes.
So could we go there and maybe try to answer Dennis, the question that Dennis posed, which is how does it look? Yeah. So here, yeah. So there, the materialized view is called what? MV. Yeah. Yeah. Okay. So let's go into MV. Okay. So MV has two tablets, right? And it looks like what is the partition key? So it looks like YB row ID, year of birth, and count. All three are the partition ID, right? So it's basically optimized for that particular query, right? So so if you go back to the query for a second.
Isn't just the YB row ID the partition key?
Oh, sorry. Yeah, actually, you're right. I can't really see properly.
It's okay. It's a little hard to read.
Right.
Yeah.
Actually, the other two are not, but all three are a part of the primary key. So if we go back, are the other two a part of the primary key?
I don't believe so.
Okay, so just the row. Oh, just the row ID is the primary. Yeah. Okay, yeah. And how do we like? Okay, so let's go back to the materialized view definition.
Sorry, just this right here. The terminal.
Yeah, terminal. Yeah, terminal.
Oh.
So yeah, let's go back to the terminal.
Yeah.
Yeah, fantastic. So could you, do you mind describing the original table, like which is base, I think? Okay, so this is a 2-part table. And if you do a /d+, let's look at the primary key on it also. Okay, so this table does not have a primary key, it looks like, right? Okay, and the materialized view therefore has count from base group by. So what does is there a way to describe I guess there is no way to describe. So the partition key for the materialized view, is that a row ID or is that the year of birth in this example?
The partition key for the materialized view.
Maybe let's do it with an
row ID, right?
It's the row ID. Okay. So now run your query. I think let's do run the 2 queries that you are going to run to show how it works. Not just the actual query against the materialized view.
Yeah. So like selecting from the materialized view. Oh yeah, sure. Yeah.
Select against the base table and the materialized view, right? Let's run that.
Okay. So if we select from the materialized view, like we can't run the select right now because I didn't populate it. So now when I refresh the materialized view, I am able to select from it. And then I can describe the materialized view.
Got it.
And now when I select where the year of birth is 1999, I see that the count is 277.
Do you mind doing a / timing on, like shall we?
Yeah, sure.
Let's see the one against the base table and this guy.
Yeah. So I'll get into that as well. I'll just demonstrate like the updation of the materialized view. Okay. So when we insert into the base table and then we select from the materialized view, the count is still 277 because we actually have to perform a refresh. And now when we select, the count is updated to 78.
Fantastic.
So now let's actually create a view which executes the same query as well and compare the timing. So if I execute the query itself, it takes me 780 milliseconds. If I execute, if I select from the view, which also executes the query underneath the hood, it also takes about the same time. And then if I select from the MV, it takes only 8 milliseconds because I've stored the results.
And creating the view is the same as creating a materialized view, except you don't use the materialized keyword. That's it, right?
Yes.
Okay.
Yeah.
Got it. Got it. Okay. So got it. In this example, can we do an explain on the one that goes against the primary table and the one that goes against the materialized view? Okay, so it's a sequential scan on base, and let's do the same thing against the materialized view.
That would be a sequential scan on the MB, right?
Got it. So yeah, so I think to answer Dennis's question, the distribution of data is by row ID in this example. And the reason the performance is better is because the number of rows in the materialized view is far smaller than the number of rows in the base table, right? And it's kind of pre-processed and maintained the way you want to see. So the counts are pre-materialized and so on, as opposed to having to do this on the fly, right? So those are the two things. Right? So firstly, your row count is smaller, so the number of rows you have to filter out or process is less, and the actual processing on the set of rows is also low because you have it ready to go. Right. So yeah, it would be. I think it's an interesting question, though, if we can allow like a notion of data distribution on the view, right? Like if we can control a different key as the primary key. Right?
Oh, yes, you can. Like on the materialized view, you can set like a specific column as a primary key. You would just have to specify that in the definition.
How do you do that?
So in the create command itself, like you can, I will have to look up the syntax because I'm not very.
No, just describe it. Yeah.
But just like you do with the table, create materialized view, MV, you can set the column and you can mark it as a primary key, and you can also like create unique indexes on the materialized view.
Oh, that's fantastic. Okay, so I think there's I think the comprehensive.
Yeah, I just wanted to keep the example a little simple.
No, makes total sense. I think people are asking more advanced questions, which is awesome. But to answer Dennis's question and I think in part to Kurt's question, so because we didn't specify the primary key on which we want to distribute data, it's assuming that it's a table without a primary key. So in this example, it's just like a regular table. The row ID is used to distribute, but if you do specify that, then it'll be used to place data accordingly, and you can get a much better speed up. So if you were doing, so if you, for example, did the same thing, but do you mind adding a where clause for the year, say 1999? From the materialized view, select this where. But
right now, this would be a regular sequential.
This is a sequential scan, right? But if we had specified that row, that column as the distribution column, that's going to be a point lookup, right?
Yeah.
Got it. Yeah. So I think that hopefully answers the question. Okay, so let's keep going. I think that was a very interesting live investigation, but that was nice.
So next, I'm going to show a more useful example potentially where we have like a foreign table and access to the foreign table is slow. So we can use the materialized view to sort of cache the result of a query on a foreign table. Sorry, just a second.
Yeah, no problem.
Okay. Yeah, so can you see the two terminals on my screen?
I can see the two, yes.
Yeah. Okay, so here I have a local table in YSQL, which has like a bunch of words.
And to YSQL with materialized. Okay, let's do it.
Yeah, and so I'm just going to, select from the table. Yeah, so you can see these are like 5 random words, and you can see that the actual count star is 10,000. And so now in YSQL, I have set up the Cassandra foreign data wrapper and built it and installed it. And I have a foreign server and a user mapping. So now I'm going to create a foreign table. And I'm going to create a view and a materialized view, both of which execute the same query. So this query essentially just counts the number of words that begin with a specific letter. And so this is what the result of the query look like.
Awesome.
So yeah, and so now I'm going to switch on timing again just to see the performance. If I actually execute the query, it takes me around 500 milliseconds. If I select from the foreign view, sorry, the view itself, it takes me about the same time. And then for the materialized view, which actually stores the results, it takes only 8 milliseconds. Yeah.
Fantastic. Fantastic.
Mm.
Awesome. And this can be and the foreign table can be any foreign table, right? In this case, you're using
Yes.
YSQL, but it can be like an Oracle or a MySQL or anything else on the other side.
As long as we have the foreign data wrapper installed.
As long as we have the data wrapper, yeah, it's connected. Yeah, that makes sense. Awesome, awesome, fantastic, fantastic. This is great. So a couple of other questions, right? Like, you know how we're building this feature on, you know, not all tables are large scale in a relational database. So there can be a lot of small tables, and we allow packing multiple tables into one tablet or shard using table groups or collocated tables, right? Does that set of features, are like collocated or collocation into a table group? Does that work for materialized views?
Yes, collocation and table groups does work for materialized.
Oh, fantastic. So I could have, for example, like say, I mean, a very typical example is I may have 300 tables inside a database, and one table may be very large, and 299 tables are small, and perhaps the materialized view is also very small. So I could put the materialized view alongside the other 299 and keep them on a single node and pin them that way, and so you can get the efficiencies of querying across a materialized view and a regular table, right? Got it. And can you do a join or an operation from a regular table and from a materialized view? Can you join across those tables? Like, can you treat it just like a table?
Yes. Yeah. Anywhere where you can, like, similar to a view, you can always just like use the MV as a reference to a query.
Got it. No, that's fantastic. Yeah. That's fantastic. Awesome. Let's see if there are other questions. I don't see other questions, or at least, okay. There's yeah, I think Dennis says thanks, makes total sense. Is there any plan to support auto refresh? I think you spoke about this, Fizaa, but maybe you might just want to cover it again.
Yeah, so with the pgcron extension, we can sort of get like a auto refresh where we, schedule the refresh as a cron job within the database. But
maybe good to just cover what is the pgcron extension, just so folks not familiar with the PG ecosystem might understand.
Basically, you can sort of schedule any query as a cron job, or like any command as a cron job within the
statement,
database.
any SQL statement to get. Okay, got it. And cron job, meaning you can, it's just like cron where you can specify an execution interval, etc. And so, okay, so the idea here is you would put the refresh command into the PG cron, and even though it's a distributed database, like Postgres is a single node database, so that might work differently. But in a distributed database, you can still do PG cron, and it'll take care of distributed scheduling, like making sure that irrespective of which node you kind of install the cron command from, it's going to kind of cluster wide coordinate and be highly available. All of that stuff it'll take care of, correct?
Yeah, I believe that is a work in progress. I'm not quite sure about
the. So that means.
So it's on the roadmap.
Got it. Yeah. So that is maybe a topic for a future YFTT. So they should join. But bottom line, I think what you're saying is put it in the cron and have it refresh at the interval, and you'll get this auto refresh semantics. And we typically also try to bundle a lot of these extensions, so you don't have to go to every node and install it.
Yeah. Yeah, so I believe that's a work in progress. But as for like similar to what Oracle does, where you have a refresh on commit, and if you like to make a update to the underlying table in Oracle, if you do a refresh on commit, it like auto refreshes the materialized view itself. That is not on the roadmap right now.
Can you do that with a trigger? Yeah. Can you do that with an insert trigger and then put it in a stored procedure which invokes the refresh?
Potentially, I would have to think about it.
Okay, got it.
Yeah.
I mean, Postgres is so amazing, right? It's like
Yeah.
a programming language in itself. Fantastic. And Kurt says this is a great YFTT. He really liked the live interactions between us, and great work, Fizaa. Totally second, great work, Fizaa, right? Yeah. And welcome, Kurt, and really glad you're joining us. I really appreciate the insightful questions as well, right? So it keeps us on our toes too. So, so awesome. Fantastic, folks. I think that puts us at time. So, don't join us again next week, same place, same time. And, to continue the conversation from engineers to engineers. And in the meanwhile, join our Slack channel, yugabyte.com/Slack, and feel free to holler at us there. Fizaa will continue to answer questions there. Thank you.
Thank you.